Hello everyone, my name is Aneta Wiśniewska from Astronomical Institute of Slovak Academy of Sciences, and today I would like to talk about solar prominence oscillations from Chromosphere to corona. And I will show you some recent work and some preliminary results as well. So the main question that basically raised up during our research is, can the prominence destabilization be heralded by the observable precursors? So we wanted to answer this question, but we wanted to focus on the oscillatory plasma motions, and we took the observational results from ground-based and spaceborne data. What is going on? Okay, thanks. In the past, the oscillations in the prominence were basically detected and named as winking filaments, and it was detected about 20 kilometer movement of 20 kilometers per second. And over the 2 decades, many researchers reported the oscillation that has different periods, beginning from the 2 minutes through 5, 4, and even 11 minutes. So there was a different regimes of the same phenomena, and therefore this is interested to investigate it further. And moreover, there is also different types of the oscillations. So we can detect basically transversal oscillations, which are mainly observed using the Doppler velocities in the Doppler shifts, but also we observe longitudinal oscillations, and those are observed in the intensity variations, and these are with smaller phase swoops. So for our target, we used spaceborne data, space observations from stereo A and solar orbiter, and these ones were in 3 or 4 channels, so similarly ionized helium, which is formed at about 50,000 Kelvin. And these are these 2 targets that you can see here. So this is our first prominence and the second one. So first is on the northern hemisphere, and the second is on the southern one. And the advantage of this observation was that actually the spacecraft were in opposition. So basically we can see these targets from the different angles. And also we have some kind of three-dimensional cuts through this through the structures, and we used for our analysis, we used a 3D adaptation of the wavelet power spectrum. This is actually a kind of adaptation from the classical wavelet approach, which was already which is well known, and it was published by Torrance and Compo in 1998. And we just adapted it to our 3D data, and it was just achieved by incorporating an initial pixel loop to process the extra dimension of our data. And this is actually a very similar method to pixelized wavelet filtering published by Nakarakov in 2028. So the first results are already published, and you are, if you are interested, then you can have a look on our results. So the first prominence was actually very quiescent at the beginning, and then we found out that the main dominant periods in this structure are the 14 to 17 minutes, and then 28 to 31. We also observed some 3 to 6 minutes oscillation in the structure, and what is important is that with our method we can actually have the kind of temporal distribution of this oscillation in the whole structure of this prominence. So unfortunately I cannot show you the movie because it doesn't work, sorry. But basically we can run through all the structure and then track this oscillation, how they are behaved in time. So for our second data set, we also took the ground-based measurement. So ground-based actually is coming from the SDDI. I forgot to mention that this is a solar telescope in Japan at the Hida Observatory. And for that we had very nice H-alpha measurement, which was probing the line profile with the very fine points here. And we have 2 time intervals for these measurements, So we were really happy that we can actually investigate the second target as well. But what is important that what we would like to investigate was the goal, how the prominence oscillate not only itself, but also how does the plasma which is surrounding the structure, because basically the prominence is hanging on some kind of magnetic skeleton, let's say. So how the surrounding hot plasma is oscillating when we detect some oscillation inside the prominence structure. So we use the upgraded coronal multi-channel polarimeter, which is UCOM, in Mauna Loa Solar Observatory, in a hot iron-13 infrared line. So we had this very nice data set, which is actually simultaneously measured with our ground-based data. So for the SDDI, we calculated the Doppler signal for our data, and we detected basically these band passes. So we have 4 minutes, 5 minutes, and then 8 minutes band pass. And also we detect very strong signal in a 15-minute band, but also using this kind of 3D interpretation. And we did the same for the UCOM. I was very curious what we got and whether these oscillations are kind of correspond to each other. This was like, I think that the first attempt that it was done this way. So we have the Dopplergrams from UCOM, which was also aligned, and then we had applied our so this is time average, our wavelength spectra. So here you can see also the same band passes as we did for the 8 alpha channel. So here you can see 4 minutes, 8 minutes, 5 minutes, and 15 minutes. And surprisingly, 15 minutes are really, really strong. So these oscillations directly correspond to each other. And we also did it for the second time series. And here you can see a little bit difference in this plot. So basically, we know that there is some evolution in the oscillation during the time, but as this is some preliminary work, we have to still work on it further. So, yeah. So our conclusions and the future work is that the main groups of the identified oscillations are short periods, so last 3 to 6 minutes, and then we also detect like longer periods in both works, so 14 to 74 minutes even. And then 8 alpha and coronal lines and dominant periods patterns are identified as 4, 5, 8, and 15 minutes inside the cold prominent core, and the same periods were found in the hot surrounding plasma. As I said, the method was 3D wavelet mapping, and it was showing full power distribution across the prominence. And this is revealing a very detailed wave behavior. So for the future, we would like to compare these observational results with the simulation of the prominence oscillations. And I'm really hoping and counting on that. And thank you very much. And if you would like to contact me, here's my email. You can have also look to my YouTube channel. And thank you.
Any question? How many prominence did you study?
So right now we have 2, but of course we would like to increase the statistics.
And also including other spacecraft and instruments, or?
Yeah. So for the first publication we had the stereo, we had AI, and we have solar orbiter. Okay. And then we wanted to go further, and then we wanted to have a look on the UCOM ground-based data.
Okay. No, if no other questions arise, okay, thank you again.